Hey, put that down! Don't make me check. Is this thing on? Don't hit your brother! Oh, sorry. Oh, okay. Math class. Yes, this is lesson 7 about maximum and minimums of functions. How do we tell the maximum and minimum of a graph? So this is back to an algebra section. We're talking about maximum and minimum. We're talking about the maximum and minimum in a y sense, as an output sense, as you might be guessing. Okay. So from before, way earlier in this chapter, we talked about increasing and decreasing parts. Where are the intervals where this function is increasing? Well, it seems to be increasing from negative infinity. So it's going uphill when it starts out at negative infinity. It kind of changes shape here a bit, but it's still increasing all the way up to negative 2. And then from negative 2, it starts to decrease. And we're decreasing all the way to 3, at which point we start increasing again forever. Okay. We don't really say what's happening at negative 2 or what's happening at 3. These places where it kind of changes from increasing to decreasing. Since f is increasing to the left of negative 2, so before negative 2 it's increasing, and decreasing after that, we say it has a maximum. By maximum, notice it's a maximum. It's not the maximum. You can kind of insert the idea local here. It has a local neighborhood maximum. It's a relative peak in this area at negative 2, and it has a maximum at x equals negative 2, and the maximum of f at x equals negative 2 is the maximum it does reach is 4. The maximum of the function is 4. Since f to the left of x equals 3, it's decreasing. It goes from decreasing, that's a decreasing, and then increasing after that. It changes from, as we kind of go down the path here, up the x-axis, it goes from decreasing to increasing, from downhill to uphill. We can say that's a relative minimum at 3. The minimum at 3 is 0. Okay. All right, so what values of any does it have a maximum? It seems to have, what values, if any, does f, at what values, I think I like that better, does f have a maximum? It has a maximum kind of right here, and it has a maximum kind of right here. This happens when x is negative, looks like negative 7, and again, there's an n in there, and again, when x is 7, what are the maxima? The maxima are 3 and 3. Justify your answer? Well, it's increasing before. It's the argument of increasing to the left and decreasing to the right of each of those points. That's all you really have to say. Look at the graph, silly. Okay. At what value does it have a minimum? Well, it has a minimum right here. This would be at 0. What is the minimum? Negative 4. Oh, domain. Domain of this whole thing? Well, it doesn't really have arrows here and here. We can kind of assume that it does. I don't have a hard point there, so I'm going to assume it goes on forever. So let's say the domain is all real numbers. If it wanted interval notation for that, I guess I might specify I want interval notation on this someday. Wink, wink. Okay, and then range. Looks like it starts out at negative infinity. I'll put the interval notation on this side. Goes from negative infinity, and I'm looking at y values, of course. Y values go from negative infinity all the way up to here, up to, guess what, that maximum. I should make sure my range has a end point that's the same as this. The value of the maximum, which was 3, and I said it included 3, so I should say that it includes 3 there. If I'm saying 3 is the maximum, then I should say 3 is the value of the end of the range, and it's included. Another way to say that is y is less than or equal to 3. If is f of x even, odd, or neither? Well, it appears to have a line of reflection here. That means it's even. It's not odd because if I flip it over, it's going to look different. If I spin it around 0, 0, it's going to look different. All right, sorry this is so small, but you have the paper in front of you, so you should be able to read that. If given the graph of f of x to the right, graph and write the equation of each transformation of f of x. Okay, so just like before, it wants us to think about some important points here. At -8, looks like we're at -4. Wow, that is really small. At 0, it appears we're at 4. At 4, we go down to -2, and at 8, we're also at -2. The domain of the transformation is -4 to 4, and the range is -6, 2, with an x-axis reflection. Okay, so right now, you can think about kind of the box that this function occupies. So I'm a little bit off with my tablet pen thing here, but this kind of has a domain originally of, well, what do these x's go between? They go between 8 and -8. It includes 8 and -8. And the range sits between, looks like -4 and +4. You could look at this picture, -4 and +4. Okay, I'm supposed to transform that, so the domain goes between -4 and +4. Well, that to me seems like it's got to be a shrink. It's got to be a horizontal, because we're talking about domain, that's x, horizontal shrink of like a half. And the range right now goes from -4 to +4. That has to end up going from -6 to 2. It looks like we have to, it's the same size, it's just shifted over. Looks like we have to translate this thing 2 units which way? The range is going from -4 to 4. It ends up going from -6 to 2. So it looks like down. We have to go down to. Now, do you think we have to translate left or right? Well, I don't think so. This thing is kind of already centered around the domain is already centered around the y-axis. It ends up still being centered around the y-axis. So I think we're okay. So this is all we have to do. Horizontal shrink and translate 2 down. So if that's true, we will probably get something like, remember the order of operations here is reflect. Think about the reflection first, then think about the stretches, then think about the translation. So the first thing to think about is the stretch. That's a horizontal shrink, so we're going to multiply by x. You know what, I'm just going to write this down here. We're going to have to multiply by, oh wait, it's a shrink. It's horizontal. So it's going to end up being a 2x in the center of the f of stuff, right? That happens inside because it's an x idea, right? The horizontal shrink. We talked about that last time. What you just quizzed over is that something that happens to x, so we kind of do the opposite of what we feel. And 2 down is just how it kind of predictably happens. The y stuff happens on the outside, and it goes as predicted, so it's like that. Let's make sure this works. So for this to work, just kind of double check here. For this to work this way, this 2x being in here, it only understands these in the inputs of f. So for those to turn out correctly, I have to divide them by 2 so that when they multiply here, they go in as something it understands. So if they go in like that, they'll come out, this -4 will come out as, because it goes in as -8 here, comes out as -4 minus 2 gives me -6. 0, f of 0 is 4 minus 2 is 2. 2 means f of 4, which is -2 minus 2 is -4. And if I put 4 in here, this is f of 8, which is -2 minus 2 is -4. Let's graph this and see if it meets these criteria. And if it does what this looks like it says it was supposed to do. So these points should be on here. -4, -6, 0, +2, 2, -4, and 4, -4. I guess I could have paused the video and done this. You would not like to watch me do this. Okay, good. It's kind of the same shape as that thing. It looks like it's been horizontally shrunk. It's half as fat as it used to be. It looks like it's, is it translated down too also? That's harder to tell, but yes, it has. See this little constant thing over here that got scooted back but also went down? But look at this top thing. It shrunk. Did it also move down? 0 with a -4 minus 2. Yeah, I guess it did because, oh yeah, horizontal shrink wouldn't have moved it at all, right? Sorry, it got moved down later. Perfect. The box that this lives in, does it have a domain from -4 to +4? Oh, sorry, oops. Yeah, it goes from, I mean, look at the x column. It goes from -4 to +4, and the range goes from -6 to +2. Perfect. That's a lot to think about. Same graph. Oh, let me copy paste that in. I told you. Oh, sorry. Okay, this thing's back now. Part B, same function we start with, so same points. That's why I copy pasted that in. Oh, just a second. I forgot my pen. I I can't draw. Over here! Oh. Okay. Maximum is at x is -2 with no reflections and no stretches or no shrinks. Okay, so I really kind of have to not think about domain or range or box, the box kind of that it occupied before. Now it wants me to translate this in terms of what happens to the maximum. So the maximum previously was at, what was the max here before? The max here before was this point here, which is represented by the 0, 4 point. So the 0, 4 point is kind of what I have to track here. Now with reflections, that might change what the maximum is, like especially if it's reflecting over the x-axis. Stretches and shrinks usually don't reflect what point gets the maximum. It might reflect or change kind of where it is or what it is. But anyway, it has to become this point here. Maximum is 0 at x equals -2. So at x equals -2, this now has to be the high point. And remember, the kinds of transformations we studied were RST, reflections, stretches and shrinks, and translations. And it says no stretches or shrinks and no reflections. So it has to be a translation that takes this point here. If we got to get this point to move here, and everything's going to slide with it, so it's going to stay on top of the pile there at the maximum peak, this thing has to move over 2 and down 4. So it has to, the translation we need here is back 2 and down 4. So to get that to happen, the stuff that happens to x goes inside here with x, and it's opposite of what it feels like. And then the stuff that happens to y goes on the outside, but it is like what it feels like. So that's the translation we're looking for. So first of all, I know that point has to go to -2, 0. So hopefully that worked out fine. The second point. So I put in -2, boom, f of 0, good. That should be 4, and then -4 is 0. Great. For this to be -8, I have to make this -10. For it to be -8 in the function, right, which will become -4, -4 is -8. So all these are going to get 2 subtracted from them. And then all these are whatever it says to do. So this is going to be this thing -4. 2 goes in as 4 in the function, which points me to -2 now as a result. -4 is -6, and this is the same one. All right, so let's graph that. -10. Oh, yeah, let me pause and do it. Yeah, you don't want to sit there and watch me do that. And my handwriting is really bad on this. Sorry about that. It's worse than it is on the Promethean board. It's this tablet thing I got to use. Okay, so hopefully that all worked out, right? This is now the maximum at 0. It's -2. This is congruent to that. Sorry, this picture's bigger and a lot wobblier. Sorry about that. Okay, and I guess that's it. Yes, that's the end of this unit. And so the test is after the next class, which is review day. So it's review day and then test, and I will see you there. And now I have to go discipline my kids. Bye.